Welcome to my video on translating equations. So in our previous lessons, we've been translating expressions. Now we're going to translate equations. And equations differ from expressions because they contain an equal sign. So fill in the word equal sign. Okay, understanding equations versus expressions here. I'm going to slide this up here. So the definition is a number sentence. So an equation is a number sentence that contains what? An equal sign. That contains an equal sign. Okay, so think about some characteristics of an equation. It has to have a what? An equal sign. Okay, that's the number one thing. It will also have operations. Addition, subtraction, multiplication, and division. It can also have, what do we call letters? Good, variables. And then, of course, it has to have what? Numbers. So let's look at some examples of equations. We're going to write down two. 6n minus 3 equals 9. So notice it has an equal sign, variables, numbers, and operations. And then 2 plus 4 equals 6. Notice it has an equal sign, it has numbers and operations. It doesn't have a variable, but it's still an equation because of the equal sign. Now here's some non-examples, and these would be examples of expressions. X, Y, Z, 5 plus E, and 6 plus 3. Okay, let's move on. When writing equations, look for keywords that can be replaced by an equal sign. Here are some words that mean equals. Is, equals, equal to, those are pretty obvious, and is the same as. So the ones we have to remember is and is the same as. And is the same as has the word is in it. Okay, let's turn the page, and here are steps to writing an equation. When working with equations, start with is and the number beside it. The equal sign can come either at the blank or the blank of the problem. Good, beginning or the end of the problem. Then work with the other side of the equation. So here's example 1. 15 is, and notice I wrote 15 equals already. And now we need to deal with this part. 4 less than the number of songs downloaded. So I'm going to circle less than. That's a switch around word. And let's use N for number of songs. S looks too much like a 5. Otherwise, I would use S. So look, this says 4 minus N, but because this is a switch around, we're going to write N minus 4. Okay, example number 2. The sum of 10 and the number of days left in school is 99. So we're going to underline sum. Is 89. So we're going to write equals 89. And then how do I write the sum of 10 and the number of days left of school? Good. 10 plus, and I'll use D for days. 10 plus D. Notice I didn't switch the order because I didn't have a switch around word, so I put the 10 first. 10 plus D. Okay, moving right along. Follow these steps to translate equations and expressions. So the first step is to ask yourself, will I have an equal sign? Take care of this first. Underline key vocabulary. Circle switch around words. than, from, or added to. Remember, comma means stop and group. And then do I need parentheses? So let's look at the first one. 15 more than, circle, a number is equal to 20. So I'm going to write that part first. So I'm going to write equals 20. Now, 15 more than a number. So 15 plus n, but it's a switch around. So I'm going to write n plus 15. Because if I want 15 more than a number, that means I'm adding 15 to the number. The number is already there. Okay, the quotient, underline, 12 in a number, increase by, underline, and is 5, underline. So we have an equals word, so I'm going to write that first, equals 5. It says the quotient of 12 in a number, stop and group, plus 7. Sorry, plus 2. Now, normally I would put this in parentheses, but I didn't write the parentheses here, and here's why. What would I do first in order of operations? I would do division. So if I would normally do division anyways before I do addition, then I don't need parentheses here. Now, is it wrong if I put the parentheses? Absolutely not. But I don't need the parentheses. Okay, number 3. 30 is, underline, twice, keyword, sum of a number and 3. So I'm going to write the equals part first. 30 equals. Now it says twice the sum of a number and 3. So I know I'm writing the sum of a number and 3. And I want to do twice that. So now I need parentheses because I'm saying twice the sum. So I'm going to multiply the whole sum by 2. And therefore I need parentheses. Okay, number 4. Half Mary's age, even though this is not on our list, we'll do a keyword here, increase by, is 12. So I'm going to write the equals part first, so equals 12. Half Mary's age. So when I take half of something, I just put the fraction in front of the letter. Anytime I take a fraction of something, I put the fraction in front of the letter. Okay, and it says increase by 5, so plus 5. Now here's an important reminder. When you're writing a fraction and a letter next to the fraction, make sure the letter is in the middle, not on the bottom, because if it's on the bottom, it totally changes the equation. Okay, moving right along. Let's look at the last page here. It says translating and solving two-step equations. So translate each verbal equation to an algebraic equation. Solve showing your work. Okay? So we're going to write these, and then we're going to show our work quickly because the two-step, when we solve the two-step, it's going to be a review of what we've already learned. So twice a number less than 4 is 28. So I'm going to write the equals part first. Equals 28. Now, twice a number less than 4. So 2n minus 4, but because it's switch around, I'm going to do 4 minus 2n equals 28. Now, remember, when we have addition or subtraction, draw your t, circle your variable. So remember, there's a minus sign in front of 2n, so that means 2n is negative. But we want to get rid of this number first. And how do we get rid of 4? We subtract 4. 4's cancel. Bring down negative 2n. 28 minus 4 is 24. Opposite of multiplication is division. Negative 2 divided by negative 2 is a 1 in disguise, so n equals negative 12. Now, we can check these, but remember, it won't check. Well, it will check no matter which equation you write, but sometimes you might write the wrong equation and still get it wrong because you wrote the wrong one. Okay, so the check is 4 minus 2 times negative 12, and we hit equals, and we do get 28. So it does in fact check. Okay, the quotient of a number and 6 increased by is 30. So we're going to write the equals part first, equals 30. The quotient of a number in 6 is n over 6. Increase by means add, so increase by 7. Okay, circle the variable and draw the t. The opposite of adding 7 is subtracting 7. What happens to the 7s? Cancel. So we have n over 6 equals 30 minus 7 is 23. And what's the opposite of division? Multiplication. So we're going to multiply both sides by 6. So I'm using the multiplicative inverse property. That gives me a 1 in disguise. So n equals 138. Now, on my check, I would do 138 divided by 6 plus 7 and hit equals, and it does, in fact, give me 30. Okay, 3 more examples. Whoops, what happened? There we go. Okay. 5 more than, circle, the product of 3 and a number is 23. So we're going to write equals 23 first. Now, let's ignore the circle words for just a second. We're going to say this is 5 plus 3n, because remember, product means multiplication. We always put the number in front of the letter. So 5 plus 3n, but because I circled that word, I know I have to switch the order of the 3n and the 5. So 3n plus 5 equals 23. Circle the variable and draw your t. The opposite of adding 5 is subtracting 5. What happens to the 5s? Slash them out, equals 0. So 3n equals 23 minus 5, 18. And the opposite of multiplication is division. So we're going to divide both sides by 3, and therefore n equals 6. Now this one's easy enough to do in our head. 3 times 6 is 18, plus 5 is 23. It does, in fact, check. Okay. 45 is the sum of negative 10 and 5 times a number. So we're going to write this part first. 45 equals, sum means add, so we're going to add negative 10 and 5 times a number. Okay, circle the variable, and this time I'm going to circle the plus sign because it's in front. That means it's positive 5n. Now, how do we cancel out 10 negatives? Good, 10 positives, so we add 10. 10s cancel out and equals 0. 45 plus 10 is 55. Equals 5n. And the opposite of multiplication is division. So we divide both sides by 5. And 11 equals n. Or we could switch it around and write n equals 11. Okay, to check it, I do negative 10 plus 5 times 11 and hit equals, and it is, in fact, 45. Okay, that brings us to our last one, and this one's a little bit tricky. Okay, we have 2/3 of a number increased by 6 is 24. 2/3 of a number increased by is 24. So we're going to write equals 24. And 2/3 of a number, that means I'm multiplying a number by 2/3, so number in front of letter. So we'll say 2/3 n, make sure it's in the middle-ish. Increased by 6, so plus 6. Now, circle the variable. We're going to solve it the same way. The opposite of adding 6 is subtracting 6. So the 6's go away. Bring down 2/3 n equals 18. Now remember, to cancel out a fraction, we use the multiplicative inverse property. That means I flip the fraction. So if I flip 2/3, what do I get? 3 over 2. Good. Now, this will turn into a 1 in disguise, and remember, when you're multiplying a whole number times a fraction, what can I put underneath the whole number? A 1. So 18 times 3 is 54. 1 times 2 is 2, and 54 divided by 2 is 27. So n equals 27. Now, when I'm checking this in my calculator, remember I do 2 divided by 3 times 27 plus 6, and then I hit equals, and it does, in fact, give me 24. Okay, that concludes our notes on translating equations and solving them. I hope you have a great day.